Hello and welcome to your math lesson for today. So we are working on Module 3 and today we are going to be doing Lesson 2, Rates of Change and Slope. So your learning target for today is, I will be able to find the rate of change and slope. I will be able to find the rate of change and slope. All right, you guys could open up your books to page 77. So if you need to, go ahead and stop the video and then go ahead and find your book and open up to page 77 so you can follow along with some of these examples and then your turn, some practice things that you can do as we are going along here. All right, so the first thing here is we are investigating some rates of change. And the rate of change is a ratio, and we've talked about ratios, that we can write it 3 to 1, 3 to 1, or 3 to 1. So when we talk about ratios, we are typically going to be writing them as fractions. Is the amount of change in dependent variable or output to the amount of change in independent. So talking about independent and dependent and input and output. So when we have an equation, there are numbers that we put into the equation and numbers that come out, and they're called the dependents because they depend on what you put in. So let's just talk about this example 1 here. Eve keeps a record of the number of lawns that she has mowed and the money she has earned. Tell whether rates of change are constant or variable. So what part is independent? Does Eve get to choose how many lawns she mows? So on day 1, she chose to only mow 1 lawn. On day 2, she chose to mow 3 lawns. Day 3, she mowed 6 lawns. Now the amount of money she gets paid is dependent. It is dependent on what she chose to do. So the amount of money depends on how many lawns. So this is called your independent part. Independent. I'm having trouble spelling today. All right, independent part. We also call those input and outputs. So we input the fact that she is choosing to mow 8 lawns, and then her output is the money that she actually gets. And remember, this is typically your X, and this is typically your Y. So when we talk about the X values, we could also use the vocabulary words of independent, or we could use independent. When we talk about Y, we are talking about your dependent variables, which is also called your output. Okay, so those are just some words that are interchangeable here. So if you need to, stop the video and get those written down in your notes so that you have a reference or something to go back to when you need that. All right, what they want to know here is if the rate of change is constant or variable. Constant, is it the same? Or is it variable, which means that it's changes or it is different? So what we're going to do here to find change typically means that we are going to be subtracting. So when we want to find the change in something, we are typically going to be subtracting. All right, so remember when we did these and we were talking about that K value yesterday, we put the Y on top and the X on the bottom. So if we want to find the change from day 1 to day 2, we are going to be using these numbers. So day 1 ordered pair is 1, 15. Day 2 ordered pair is 3, 45. And they want to know what this rate of change is and if it is the same or if it's different between day 1 and day 2, between day 2 and 3, and between 3 and 4. Okay, are they the same or are they different? So we actually have to do 3 different problems here to answer this question. All right, so to find the change, what we're going to do is we're going to take the change in the Y values. So our y values here are 15 and 45. So we're going to do 45 minus 15. And then on the bottom, we're going to put our x values. Now I did 45 minus 15, so I have to do the other numbers in the same order. So I have to go bottom to top. So I have to go bottom to top. So I have to do 3 minus 1. So 45 minus 15 looks like it's going to be 30. And 3 minus 1 is 2. So 30 divided by 2, this comes out to be $15 per lawn. Okay, so on day 1 to day 2, that was $15 per lawn. All right, now I'm just going to erase this data. I'm going to leave this answer over here, but I'm going to erase part of this. And now we're going to do from day 2 to day 3. So I'm going to leave that up there just so we can compare it. But now I'm going to go from day 2 to day 3. So day 2, that ordered pair is still 345. And day 3 is 690. Okay, so I'm going to do the same thing, y over x, over x. And so I have 90 minus 45. Remember, I have to do the y values on top. And then I'm going to do, so I did bottom to top again, and then I'm doing 6 minus 3. Can anybody think why I did bottom to top and not 45 minus 90? And the reason I did that is because now my numbers are staying positive. So I have 45, and 6 minus 3 is 3, and 45 divided by 3 is 15. So again, we ended up with 15. All right, now I have to do it one more time. So I'm going to put day 4 data here. Day 4, that ordered pair is 8, 120. So I have to do the same thing, y on top, x on the bottom. So I'm going to do my y values. Again, I'm going to do bottom to top because my numbers will stay positive. So I have 120 minus 90, and then I have 8 minus 6. So 120 minus 90 is going to be 30, and 8 minus 6 is 2. So that comes out to be 15. So between every interval, every change came out to be 15, 15, and 15. So is that a constant rate of change or variable? Well, it's the same. So it is a constant rate of change. All right, so here's another problem for us to try on our own. So find the rates of change. So I'm going to have to find this rate of change here. So I have 18. Remember, we always have to do the y's on top. So I have 18 minus 0 and 0.5 minus 0. So I have 18 divided by 0.5. And remember, you guys can grab your calculators. So 18 divided by 0.5 is 36. All right, then I also have to do this change from here to here. Remember, this is x, this is y. My y's go on top. So I'm going to do 31 minus 18. So again, I went bottom to top. And now I have 1.5 minus 0.5. So 31 minus 18 is 13. And 1.5 minus 0.5 is 1. So that comes out to be 13. Well, right now, we can answer the question, are these rates of change constant or variable? Well, between these first two right here, we can see that we got a 36 for the first one and a rate of change of 13 for the next one. So that means that even though it is starting right here at 0, 0, we had a rate of change that went 36, and then the next rate of change went 13. Is that a nice, constant, straight line for a constant rate of change? And it's not. So that's why we end up with a variable rate of change here. That would not be a straight line. All right, so we've got the same thing going on here, only we've got some bubbles and different things. So they want to go from hour 1 to hour 2. So you can see you have 30 minus 15, and then 2 minus 1. So they went top to bottom. 30 minus 15. 30 minus 15 is 15. So we got 15 miles an hour. Well, before we fill all of this in, do we already know what the answer should be? Is this going through 0, 0, and is it a nice straight line? So there are two things we can say about it. It is proportional because it is going through the origin, and it is a constant rate of change because that is a nice straight line, constant rate of change. So do we know that all of these answers should come out to be the same? So now in the second one here, they want us to go from hour 1 to hour 4. Hour 1 to hour 4. Okay, so we're picking two different ordered pairs. So again, they're starting at the top, going to the bottom, 60 minus 15, and 4 minus 1. So 60 minus 15 is 45 divided by 4. So 45 divided by 4 is 15 miles an hour. So does it matter which ordered pair I picked? No, because this is a nice straight line. Should the change between them always be constant? And that answer is yes. All right, moving on. Okay, so does a proportional relationship have a constant rate of change? Yes. And does it matter which interval you use? No, should be the same. Okay, it doesn't matter which two you picked. They should be the same if we're going to have a constant rate of change. All right, finding slope here. So finding slope is going to be rise over run. Do you see how it's the constant rate of change? We're doing the exact same thing where we're taking those y values on top and subtracting and the x values on top. And we call this rise over run. So if you have a graph, it's kind of nice. We can start from one point and another point, and you can just count. If it's nice and graphed, you can count. How many is it going up? Well, it's going up 2. It's rising 2. And then it's running 1, 2, 3. So there is your constant rate of change. Now, if I were to start at the origin, it would be the same thing. Up 2, and then over 3, and we get to that point. So it doesn't matter which 2 I take. All right, so let's count this one here. So we have this point here. And how many is it rising to get even to that point? Well, we rose 2. So rise over run. Now, how many are we running? How many are we going over? 1, 2, 3. And which direction did I go? I went negative, so it should be negative 2 over 3. Now, some kids write it 2 over negative 3, which I will mark that correct. Or another way to write it would be 2 over 3 with the negative even with that. So a lot of kids just put that negative with the number that they are using. All right, let's try another one here. So they're asking us to find the rise. So we have a dot here and a dot here. So how many are we going up to be even to that dot? 1, 2, 3. It looks like we're rising 3. And how many are we going over? 1, 2, 3, 4. So your slope, remember it's ratio of rise over run. So this should be 3 over 4. Your slope will always be written as a ratio or a fraction. It is not an ordered pair, it's rise over run. All right, so make sure you stop this video, try this, count it out, and see what you get for an answer before you resume. All right, start at this dot, go to this dot. 1, 2, 3, 4. So we're going to rise 4. Now how many am I going to run? 1, 2, 3, 4, 5, 6. And now we have to simplify, so reduce this, divide by 2, divide by 2. So let's see, if I went up 2 and over 1, 2, 3, oh, look at that. I got another point right on that line. All right, finding the slope of this one. The first thing I notice is that it is negative. So I'm going to count up 1, 2, 3, up 3, and over 1, 2, 3, 4, 5. So we have a negative 5. All right, good luck on your homework.